Good morning, friend. I am today discuss next topic of OAD subject. Here I'm sharing screen. As previously I discussed about two topics: introduction to UML and importance of UML modeling. Now I'm moving to the next topic: principle of modeling. This is an also very important because as I discussed previously, if we are talking about introduction of modeling and importance of modeling, then principle of modeling is also very important, because if we are going to design any model, what are the principle behind that particular model is very important. So here I'm explaining the principle of modeling, mainly four principle of modeling, such as I am here mentioning. One, the choice of what models to create has a profound influence on how a problem is attacked and how a solution is saved. Here, by the first principle of modeling, as I read out or explain in front of you, the choice of what models to create has a profound influence on how a problem is attacked and how a solution is saved. The right models right will brilliantly illuminate the most bad development problems, offering insight that you simply could not gain otherwise. The wrong models will mislead you, causing you to focus on irrelevant issues. In software, the models you choose can deeply affect your world view. If you build a system through the eyes of a database developer, here I am explaining a different person who developed the system in the eyes of that database developer, you will likely focus on entity relationship models that push behavior into triggers and stored procedures. If we are talking about the eyes of database developer, then the model express the entity relationship models that push behavior into trigger and stored procedure, as I told before. And next, if you build a system through the eyes of structured analyst, if I am talking a person of development model who is the structured analyst, in the eyes of structured analyst, we will likely end up with models that are algorithmic centric. It means in the eyes of a structured analyst, he will centralize the model on the algorithmic centric, with data flowing from process to process. This is centralized. The model is centralized on the algorithm part of the software development. If we are talking about a system through the eyes of an object oriented developer, it the person, here I'm again explaining a third person, the views of different persons, how to create a model in the views of different person. I'm explaining in this particular one principle of modeling. In the third person, if you build a system to the eyes of an object oriented developer, you will end up with a system whose architecture is centered around a sea of classes, and the patterns of interaction that direct how those classes work together. The object-oriented developer centered on the classes and patterns of the interaction that direct how the classes work together. Any of these approaches might be right for a given application and development culture. All those experience suggests that the object-oriented view is superior in crafting resilient architecture, even for systems that might have a large database of computational element. That fact notwithstanding, the point is that each word view leads to differently kind of system with different cost and benefits. This is the main function of these points, how a system is designed in the different person's view. I'm moving to the next point. Every model may be expressed at different levels of precision. The best kind of models are those that let you choose your degree of detail depending on who is doing the viewing and why they need to view it. The focusing on depending on who is doing the viewing and why they need to view it. An analyst or an end user will want to focus on issues of what a developer will want to focus on issue of how. Both of these stakeholders will want to visualize a system at different levels. Here also I'm explaining in the different two manners. First one is a user and second one is an analyst. Both are on the different. So a developer will want to focus on issues of who. Both of these stakeholders will want to visualize a system at different levels of detail at different times. The user and analyst have different level of interaction with the model and their aspects, which is very important in designing of the principle or designing of a model. Moving to the next point, the best models are connected to reality. This is a very important, a very useful for any modeling. It is best to have models that have a clear connection to reality, and where that connection is weak, to know exactly how those models are, how those models are divorced from the real world. All models simplify reality. The trick is to be sure that your simplifications does not mask any important details. In software, the structure analysis technique is the fact that there is a basic disconnect between its analysis model and the system design model. Failing to bridge this gap, failing to bridge this gap causes the system as conceived and the system as built to diverge over time. In object-oriented system, it is possible to connect all the nearly independent views of a system into one semantic whole. moving to the next point, no signal, no single model is sufficient. Every non trivial system is best approached through a small set of nearly independent models. If you are constructing a building, there is no single set of blueprints that reveal all its details. At the very least, you will need floor plans, elevations, electrical plan, heating plan, and plumbing plans. The operative phrase, phrase here is nearly independent. In this context, it means having models that can be built and, and studies separately but that are still interrelated. The same is true of object-oriented software system. To understand the architecture of such a system, you need several complementary and interlocking views. A use case view, a design view, a process view, an implementation view, and a deployment view. Here I'm explaining you a use case view exposing the requirements of the system, and a design view capturing the vocabulary of the problems. Vocabulary of the problem space and the solution space. A process view modeling the distribution of the systems, process, and threads. An implementation view addressing the physical realization of the system, and a development view focusing on system engineering issue. Each of these views may have structural as well as behavioral aspects. Together, these views represent the blueprints of the software. Here, all four modeling principles are explaining. Now, I am moving to the next, object-oriented methodology. After discussing above three, introduction of UML, importance of UML, and principle of modeling. When we are going to design a model, when we are discussing about a model, the main three functions are done. When we know what is this, it means introduction. What is this? What is UML? Now we are studying UML, and after that, why UML? It means what is the importance of UML. The second thing, and third thing, what are the principle on which we are developing our model. And next, I am moving to the how to the develop these models and what are the tools used to develop a UML model or a modeling phrase. Here, I am moving to the next topic, object-oriented methodology. Here, several object-oriented methodology are present. Some some are I am mentioning here. First one is Ramberg Object Modeling Technique, in short OMT. And second one is called Jordan Object Oriented Analysis and Design, OOA, and OOD. Boost Object Oriented Design, and Sailor Miller, OOA, OAD. These are the several object oriented methodology or tools are here to develop a model for a software product or non-software products. I am going to the explain with the in a very brief manner. First, Ramborg object modeling technique. This OO methodology is documented in object oriented modeling and design by James Ramborg. It has a strong data modeling origin. It has a very comprehensive graphic notation. Analysis in OMT consists of the object model, dynamic model, and functional model, which will be described shortly. Analysis is followed by system design and detailed design. This Rambo object modeling technique is basically define the object model, dynamic model, and functional model, which will be described shortly. Next, moving to the next point, code your down object oriented analysis and design. This OO methodology is documented in object oriented analysis and object oriented design by Peter Cod and Ed Jordan. It has a strong data modeling origin. It has a simple graphic notation. OOA, object oriented analysis, consists of identifying and organizing classes from different points of view called layers. Object oriented design consists of refining the object oriented analysis model for the human interface, problem domain, data management, and concurrent task management. Now here I am explaining the next methodology, which is concerning on two object oriented analysis and object oriented design. And object oriented analysis organize the classes and in the different layers, and object oriented design is refining the object oriented analysis within the model, and this will be define human interface, problem domain, data management, and concurrent task management. Moving to the next point, Booch object oriented design. This OO methodology is documented in object oriented design with applications by Grady Booch. It has a very strong real-time and message passing origin. It has an extensive, comprehensive graphic notation. OOD consists of modeling a system by identifying, organizing, and specifying subsystem classes, objects, implementation models, and phrases. These all points are concerned in the Bush object-oriented modeling or include in the Bush object-oriented modeling. Next, moving to the next point, Shaler Saller Mellor object oriented analysis and design. This OO methodology is documented in object life cycle modeling. The word in state by Sally Saller and Stephen Maller. OOA, object oriented analysis, consists of information models, state models, and process models. Similar to OMT, object model, dynamic model, and functional model, OOD consists of refining the OOA models for an implementation environment. Now, all about the object oriented methodology. Now we are moving to the next phase. What the object oriented model? I am defining in a different manner. In the first manner, I am defining what is UML in the head of introduction of UML, and second, why we use UML, what is the importance of UML, and moving to the next, principle of UML or principle of modeling, and next, what are the technique, what are the methodology are used to develop a model. Now moving to the next topic, which is related to the object oriented modeling. What is object oriented modeling and why we done it? Object oriented modeling, in the previously we are studying object oriented modeling in two aspects. Object oriented modeling are discussed by two different approaches or two different perspectives. First one is algorithmic perspectives and second one is object oriented perspectives. Here I am first defining and explaining about algorithmic perspective. It is an algorithmic approach which takes building block as collection of function as previously designed structure for a code for a software development. Every person and every developer and every analyst are basically concerned of on the algorithm portion of a particular software. That particular algorithm is a collection of functions which are going to be built. Here I am explaining the traditional view of software development take an algorithmic perspective. In this approach, the main building block of all software is the procedure of function. This view leads developers to focus on issues of control and the decomposition of larger algorithms into smaller one as requirements change and the system grows. Systems built with an algorithmic focus turn out to be very hard to maintain. The contemporary view of software development takes an object-oriented perspective. In this approach, the main building block of all software system is the object or class. An object is a thing generally drawn from the vocabulary of the problem space or the solution space. A class is a description of a set of common objects. Every object has identify, identity, state, and behavior. For example, consider simple three-tier architecture for a billing system involving a user interface, middleware, and a database. In the user interface, you will find concrete objects such as buttons, menu, and dialog box. In the database, you will find con- concrete objects such as tables representing entities from the problem domain, including customers, products, and orders. In the middleware, you will find objects such as transaction and business rules, as well as higher level views of problem entities such as customers, products, and orders. This is a algorithmic perspectives. Now moving to the object oriented perspectives. It is an object oriented approach, or we can say object oriented modeling is entirely a new way of thinking about problems. This methodology is all about visualizing the things by using models organized around real world concept. Object oriented models helps in understanding problems, communicating with experts from a distance, modeling enterprise, and designing programs and database. We all can agree that developing a model for a software system prior to its development or transformation is as essential as having a blueprint for large building essential for its construction. Object oriented models are represented by diagrams. A good model always helps communication among project teams and to assure architectural. Object-oriented modeling is a suitable modeling technique for handling a complex system. This is all about the object-oriented perspective. Both are different to each other, and the new technique which we are using for nowadays for developing the new code in new style in new technique, so we are using object oriented perspective. OOM basically is building a model of an application which includes implementation details of the system. During design of the system, object-oriented modeling, identification, and organization of application with respect to its domain is done, rather than their final representation in any specific programming language. We can say that object-oriented modeling is not language specific. Once modeling is done for an application, it can be implemented in any suitable programming language available. So, by the use of object-oriented perspective, we can easily say that the model of the particular application is suitable for any programming language is available. Now, moving to the next portion, process of OOM. What are the processes used in designing object-oriented modeling? Now moving to the next point, and here I am explaining some OOM passes through the following phases: object-oriented system analysis, system design, object design, and object-oriented programming. Now I am I am explaining this topic in next lecture. Thank you.